Let's now look at our second language processing task, namely transforming a book into one sentence per line format. And let's look at the life of b.txt file again. So less life of b.txt. So sentences here actually frequently span over a new line, like here. This sentence actually spans 4 lines. So I'm going to quit this now. Instead, I'd like to have a file like this, life of b.sent, where we have exactly one sentence per line. So this is one line, and that's another long line. This can be pretty useful if we want statistics over how often a word like queen, for instance, occurs in the same sentence as a word like hive. And another application is if we want to analyze all the sentences in the text using some kind of grammatical analysis program, then we also need to be able to process one complete sentence at a time. Let's quit this. Now, splitting a text into sentences is kind of tricky to get completely correct. But if we're interested in statistics about sentences, then it's acceptable to have a little bit of mistakes in there, as long as most sentences are correct, because we can still see the broad patterns. So let's look at this life of b.txt again, using less. We can see that we kind of have two cases here. Sentences can be separated by empty lines, as these two sentences, for instance, or they can be separated by punctuation, like here. And punctuation, of course, would include things like full stops and probably exclamation marks and question marks as well. So our strategy will be the following. We'll introduce sentence boundary symbols into places where we identify a sentence boundary, and then we convert those into new lines. So let's quit less using Q and start. Now the first thing was to insert sentence boundaries on empty lines. But there's something we need to do first. Life of B is actually a text file which is meant for Windows. This means that its line feeds look a little bit different than Unix line feeds. In Unix, a line feed consists of a single new line character, whereas in Windows, it's a combination of a new line and a carriage return. And to make Unix correctly recognize empty lines, we need to get rid of those carriage return characters. And we do this using the command dos to Unix. So cat lifeofb.txt, and then pipe it to dos to Unix. Okay, now that this is taken care of, let's insert sentence boundary symbols on empty lines. We do this using the command sed or stream editor. So sed, and then in single quotes, s and 3 forward slashes. And now, the first thing we need to specify is what we want to replace. And we want to replace empty lines. And the way you signify an empty line is by a character followed by a dollar immediately. And this is because, as you can remember, a caret referred to the beginning of a line, and a dollar referred to the end of the line. So this is a line which begins and ends in the same position, so it's empty. And then this we're going to replace with a hash sign. Now I chose the hash sign because it doesn't occur in lifeofb.txt, which you can see using grep. Okay, let's pipe this to less and see the result. All empty lines now indeed have sentence boundary symbols or hash signs. So the next step is to find the line internal sentence boundaries. Like here, for instance. Let's quit this. So the first thing we need to do is to transform this book into one long line. And we do this by replacing all new lines with spaces. Now let's look at this using less. And we can see that we just have a one very long line here. Now we'd like to identify places where we have a punctuation indicating sentence end, like a full stop or a question mark or exclamation mark, followed by a space and an uppercase letter. And this is going to be good enough for our purposes. We're going to say this is a sentence boundary. We can use sed for this as well. So let's quit less first. But now we need to use capturing to capture the final punctuation character on the left and the uppercase character on the right, so that we can reconstruct them in the output again. So let's say sed, and then dash uppercase E. And the uppercase E allows us to use a nice extended regular expression syntax, which is much less convoluted than the old or regular expression format that sed uses by default. And then again, as usual, in single quotes, S and 3 forward slashes. So what I'm looking at, or what I want to find, is a sentence final punctuation. So that's a full stop, question mark, or an exclamation mark, followed by a space, and then an uppercase letter. And to be able to reconstruct these in the output, we're going to capture them in parentheses. So what we want the output to look like is the original punctuation character, which is whatever matched the first parentheses, and then a sentence boundary symbol, a space, and the uppercase letter which starts the next sentence. And that's going to be \2 because it's whatever matched the second parentheses. And now we want to use the option G for global, which means that we perform this in every position of this long line where we have a punctuation character that ends a sentence on the left and an uppercase character starting the next sentence on the right. And let's spike this to less and see what happens. And this looks pretty good now. So for instance, here we have a sentence boundary. We correctly identify the sentence boundary here. But we can also see that we got a little bit too many of these. So for instance, here where we have these Roman numerals at the beginning of the sentence, it seems like we got an extra sentence boundary there. So let's remove some of these. I'm not going to do this perfectly. So to remove a sentence boundary symbol, hash symbol, which is preceded by something resembling a Roman numeral, we can do this. So sed again, -E for the extended regular expression syntax, and then S and 3 forward slashes. What we want to match, which is anything resembling a Roman numeral, which always ends in an uppercase I, V, or X, or typically at least. And then a following full stop and a hash sign. And what we want to replace this with is just the Roman numeral. So we capture it in parentheses and replace everything with \1, which means whatever matched the first parentheses. And let's do this globally again. We want to do it everywhere on this long line where we have these Roman numerals. And now let's check using less. And we can see that the extra sentence boundaries are now gone. Now, as I said before, this is not perfect. This probably doesn't insert boundaries everywhere it should, and it probably sometimes inserts a boundary somewhere where we shouldn't have a sentence boundary. However, it's going to work pretty well. Of course, if you really need to have a very accurate system, you'll have to improve upon this. Okay, let's quit less. Okay, so the last step is to actually transform these sentence boundary symbols to new lines and tidy up a little bit. So we basically use tr to transform this hash sign into a new line. And let's check at the result using less. Now, unfortunately, we get a little bit of extra new lines and spaces at the beginning and end of lines, which are left over from the earlier file, and also introduced by some of our tr commands. So we can remove those using sed commands. So quit less, sed, and we remove all spaces at the beginning of a line. So we have the start of a line, and then we remove however many times space occurs at the start of a line. And removing means that we replace it with nothing, the empty string. And then let's do the same at the end of the line. So here we have a space occurring start times, which is arbitrarily many times, and then $, which means the end of the line, and we replace this with nothing. So let's check using less. And now we no longer have any extra spaces at the beginning of the line, and actually no extra spaces at the end of the line either. Let's quit. We still have these empty lines, so to get rid of those, we can use the grep command. So we're going to grep inversely using the option V. So we want to find all lines which are not empty lines, and if you remember, empty lines were signified by a caret and a $. So lines where the line starts and ends in the same position. And now if we check using less, we can see that we have this nicely one sentence per line format book here.